Good day, everyone. I am Dominica De Serra from UP Mindanao and the leader of the project entitled Value-Added Product from Fruit Processing Waste, Acetic Acid for Potential Industrial Application. My co-project leader is Professor Jennifer P. Fronteras, and Ms. Daisy Bello and Ms. Kathleen Joy de los Santos are our research and administrative staff, respectively. Before I start with my presentation, let me first express my thanks to DOST through PCIEERD for providing the financial support and technical advice to our team. Waste from fruit peels pose increasing disposal and pollution problems as they represent a large fraction of the fruit. One mitigating measure to address this concern is conversion of this waste into high-value products. The general objective of the study was to investigate the potential of using food processing waste to produce value-added products. Specifically, the project aimed to determine the physicochemical characteristics of fruit peels, to produce acetic acid from fruit peels using individual fruits and mixtures of extracts, including the pasteurized liquid from Davao Thermobiotech, or DTBC, which is a local solid waste treatment facility in Davao, to determine possible pesticide contamination of fruit peels before and after processing, and to determine the economic feasibility of producing acetic acid. Physicochemical characterization using AOAC method showed an initial sugar content of 12.6% for banana peels, 11.61% for pineapple peels, 14.24% for calamansi peels, 18.65% for mango peels, and for mixed fruit, it's 21.38%, and for DTBC, it's 6.24%. Further, the pesticide residue analysis in the peels revealed that organochlorines, where 20 compounds were analyzed, organophosphorus, where 19 compounds were analyzed, and pyrethroids, where 17 compounds were analyzed, are way below the maximum residue limit set by regulatory agencies. Processing the peels to achieve various sugar concentrations of 15%, 20%, and 25%, and the subsequent addition of the yeast Saccharomyces cerevisiae allowed the peels to undergo anaerobic fermentation to produce ethanol. Aerobic fermentation of the extract with Acetobacter acetate converted ethanol to acetic acid. Now, these figures show the result of the laboratory scale analysis. Among the samples used for fermentation, banana peels seem to produce a relatively higher acetic acid concentration at the shortest possible time. It was therefore selected as raw material for pilot scale study. After anaerobic fermentation, the maximum amount of alcohol obtained was 10.12%, which were then subject to aerobic fermentation to produce acetic acid at 4.66% on day 19 with a pH of 3.31 and room temperature. The total fermentation time was 30 days. A feasibility study was done using cost volume profit or CVP analysis to determine the commercial viability of acetic acid production from banana peels to be sold as a non-toxic herbicide. Assuming 20,000 liters of acetic acid per month, the CPP projection revealed that the actual cost of production is much less than the assumed selling price. And since the total production cost is less than the profit margin, the business is profitable for the company. The plant design was also based on 20,000 liters capacity, and this describes actually some design considerations of the plant. The turn-up ratio of 120% and turn-down ratio of 50% were assumed in the plant design. Now, this figure shows the process flow chart for a full-scale acetic acid production. Aside from the unit operations identified here, a wastewater treatment facility is also included to comply with the regulatory requirements. Indeed, utilization of food processing waste can produce value-added products which can be economically feasible. This waste management option prevents the loss of valuable biomass and nutrients which would have been disposed in landfill, causing the generation of foul odors and leaching of undesirable organics, resulting in the pollution of groundwater. With regards to challenges, of course, just like other research projects, we have also encountered several challenges, foremost of which was the pandemic. A team member got positive in COVID, and most of us have been identified as F1 and F2 and had to undergo quarantine, which has actually hampered the project implementation. Also, during the lockdown, the fruit processing factories were closed, so the raw materials were not available. This prompted us to request for an extension, which was graciously granted by PCIEERD. With the extension, we were able to meet all the project objectives. Let me end this presentation by again thanking PCIEERD, including the fruit processing factories which support the project, and to everyone who, in one way or another, has contributed to the success of the project. Thank you very much.